Hi, welcome to DY India Tech. So today we are going to learn basic overview of Kubernetes. As you know, everyone, Kubernetes is a orchestrator which is very popular in containers. So let me begin. Before that, if you are new my channel, so please subscribe my channels for valuable content and hit the bell button. So let me Kubernetes is the most popular orchestrator for deploying and scaling containerized system. You can use Kubernetes to reliably build and distribute your application in the cloud. So today we learn three things. What is Kubernetes? Kubernetes features. How does Kubernetes work? So what is Kubernetes? Kubernetes is an open source system that automates container deployments. Task it was originally developed by Google but is now maintained as a part of the Cloud Native Computing Foundation, short form CNCF. Kubernetes has risen to because it solves many of the challenges around using container in productions. It makes too easy, launch limitless containers, replica, distribute them across multiple physical hosts, and set up networking so users can reach your service. What is Kubernetes used for? Kubernetes is used to manage and scale applications running in containers which are small, isolated environment. It simplifies that reliable management of numerous apps and services, even when they are distributed across multiple servers. Next is Kubernetes automates things like starting new apps when needed, restarting app if they crash, spreading out work so that no one part of the system is overloaded, scale up and scale down based on demand. Point number two is Kubernetes features. Kubernetes has a comprehensive feature set that include a full of capabilities for running container and associated infrastructure. So first is automated rollout, scaling and rollback. So this heading is, it means like automated rollout, scaling and rollback. Kubernetes automatically create the specified numbers of replicas, distributes them onto suitable hardware and take actions to reschedule your container if a node goes down. You can instantly scale the number of replica on demand or in response to changing conditions such as CPU usage. So for auto scaling in Kubernetes, we can set the threshold of CPU. If example, if we want to increase our number of pods for a particular service, so we have to set a auto scaling and rollback plan. So for auto scaling, we will set CPU base. So let's suppose if my CPU is reach 60%, my number of pod will be increases. Okay. Next is service discovery, load balancing, and network ingress. Kubernetes provide a complete networking solutions that covers internal service discovery and public container exposure. Stateless and stateful application. So in the Kubernetes is a container platform. So here you have to deploy only stateless application. While Kubernetes initially focus on stateless containers, it's now also got built-in objective to represent stateful application too. You can run any kind of application in Kubernetes. Storage management. Persistence storage is abstracted by a consistent interface that works across providers, whether in the cloud, on a network share, or on a local file system. Next is declarative state. Kubernetes use object manifests in YAML files to define the state you want to create in your cluster. Applying a manifest instructed Kubernetes to automatically transact clusters to the target state. You don't have to manually script the changes you want to see. What across environments, Kubernetes can be used in the cloud at the EDGE or on your developers workstation. Many different distributions are available to match different use cases. Major cloud provider like AWS and Google Cloud offers managed Kubernetes services, while single node distributions such as Minikube and K3s are great for local use. Highly extensible. Kubernetes pack in a lots of functionality, but you can add even more using extensionally. You can create custom object type control, and operators to support your own workload. Point number 3, how does Kubernetes work? Kubernetes has a reputation for complexity because it has several moving parts. Understanding the basics of how they fit together will help you start out on your Kubernetes journey. Kubernetes architectures, the basic fundamentals. So first is UI and CLI. So you can access Kubernetes through UI and CLI. The major component is in the cluster control plane, which is reside inside the master. The list of components inside that API servers, schedulers, control managers, and etc. This four contains is inside your master node. Then you have to decide how many worker node you require. Minimum 2 worker node is required if you building the cluster. So at least 2 worker node is required. Okay. Why 2 worker node is required? One also can handle, but if you are building a cluster, so minimum 2 worker node and 3 master is required. Okay. Because if you put a one, your website is goes down. Okay. So in this case, we have to minimum 2 worker nodes and 3 masters. Worker node you can add in futures as per your workload will increase. Okay. So in the worker nodes, there is number of pods is running. Inside the pod, the container is running. So one pod can run multiple containers or one pod can run one container. Is depending upon your usage and your solutions. If require like interdependent pod any services, so you can run in the same pod two containers. So every node need to be run kubelet, kubeproxy, and Docker should be installed. So Docker is a runtime container. Let me move. A Kubernetes environment is from a cluster. It includes one or more nodes. A node is simply a machine that will run your containers. It could be physical hardware or VMs. As I explained you earlier, like we can use one worker node or more worker node. Okay. The cluster has nodes and a control plane. That control plane coordinates the entire cluster operations. Schedule new container on to available nodes and provides the API servers that you interact with. It's possible to run a cluster with multiple control plane instance to create a high availability setup with greater resilience. So to follow a best practice, minimum we have to go with 3 masters and 3 workers. Later you can, as per your consumption. You can increase your number of workers count, or you can increase your existing worker compute. Let me move next point. So here are the most important Kubernetes elements. Okay. So first is Kube API servers. This is the part of control plane that runs the API servers. It is the only way to interact with a running Kubernetes cluster. You can issue command the API servers and using the kubelet CLI or HTTP client. Kube control managers. The control managers start and run Kubernetes built-in controllers. A controllers is essentially an event loop that applies actions after changes in your cluster. They create, scale, and delete objects in response to events such as an API request or increased load. Kube scheduler. The kube scheduler assigns new pod containers onto the nodes in your cluster. It establishes which nodes can fulfill the pod's requirements. They select the most optimum placement to maximize performance and reliability. So Kube scheduler just assign the new pod to identify which worker node have maximum capacity. According to that, Kube scheduler scheduling the pod in particular workers node. Moving to next important key points is kubelet. Kubelet is a workers processes that runs on each of your nodes. It maintains communications with the Kubernetes control plane to receive its instructions. Kubelet is responsible for pulling container image and starting containers in response to reschedule request. So basically is a kubelet is just communicating the control plane and it is responsible to pulling the image and start the containers. Okay. Next and the last, kube proxy. Kube proxy is another component found on individual node. It configures the host networking system so the traffic can reach the service in your cluster. So thank you for watching this video. We will meet in next video.